Okay, so for this, we need to find where the function is increasing. We have the function of x is equal to 5 sine of x plus 5 cosine of x, so we have a trigonometric function. We're going to find the derivative of the function first. So 5 sine of x is going to equal cosine of x. 5 cosine of x is going to equal negative sine of x between 0 and 2 pi. For trig functions, it's always going to be between 0 and 2 pi because trig is the ratios of the sides of triangles. So it's always going to be between 0 and 2 pi. We're going to find the critical points, and a critical point is going to be where the derivative doesn't exist or when it's equal to 0. In the case of the trig function, we're just finding where it is equal to 0. So we have the 5 cosine of x minus 5 sine of x. 5 and 5 are the same constant for both, so they're equivalent in that sense. So then you can set one equal to the other and then just divide out the 5, and then you'll be left with cosine of x is equal to sine of x. And there are going to be a couple of places where they're equivalent. And if you think of it in terms of the magnitude of the cosine of x is the horizontal magnitude length of the side of the triangle, and the sine of x is the vertical magnitude or length of the triangle. There are going to be two places where those are equal to each other. And that's going to be at right there in the middle. We're going to have pi fourths. Notice that cosine of x has the same magnitude of sine of x. And on the opposite end of the unit circle, 5 pi fourths, where again, you have negative sine and negative cosine having the same magnitudes and direction. Or not direction, but same sign, so it equals a positive value. So you have pi fourths, and you have 5 pi over 4. Those are your critical points. Those are where this function will be true, where cosine of x is equal to sine of x. Now we need to find where the function is increasing and where the function is decreasing. The function will be increasing when the derivative is positive. The function will be decreasing when the derivative is negative. And now we're going to create test points between 0 and 2 pi because you can only have values between 0 and 2 pi for a trig function. We know our critical points are pi fourths and 5 pi fourths, so those are going to be our boundaries. So you just put in any test point that's lower than pi fourths and see if it's positive or negative. Here you can see that pi 6, you can clearly see that the magnitude of cosine is much larger than the magnitude of sine. And then we have cosine minus sine, so a larger number minus a smaller number is going to be a positive value. You can do that without actually even doing any math. You can kind of do it in your head by just looking at the actual magnitudes of the values. At pi, you can see that cosine is negative 1. Negative 1 minus 0, sine is 0, is just going to be a negative value. So you can see that at pi, the derivative is negative and the function is decreasing. And then you test a point that's above 5 pi fourths. And if you put in any point, you can use any point above 5 pi fourths. In this case, 3 pi halves. And without even doing any math, you can see that you have negative 1 as your sine, and you have 0 as your cosine. So if you have 0 minus negative, any number, that's going to be a positive value. And you can see that the derivative is going to be positive. So the intervals where the function is increasing and has a positive derivative are going to be between 0 and pi fourths and 5 pi fourths to 2 pi. And that's it.